Tacke. Thank you for choosing this talk as the first one today. I'm Adrianne Tacke, and I am here to talk to you today about document databases and data modeling. So, who here has heard document databases are schemaless? Raise your hand. Okay. Who here has worked with a document database? MongoDB, DocumentDB? Okay, good. And who here thinks, when you think of documents, you don't think of a data model. You think of flexibility. You think the schema doesn't have to be there, or the point of schemaless is that there is no schema. What data model, right? When you think of document databases, the whole point of you wanting to use one is maybe because it is a flexible schema. But the thing is, while flexibility is great in theory, it's not great in reality. The fact is, there's some kind of structure that is surrounding all of the data that we use. The point is the way we interact with it, the way that we use it in our applications, the way that we make sense of it and why it's valuable to us. The relationships that surround that data is the reason why it's so useful. So even though we may like to say, gracias, that it doesn't matter or that we may not need a data model, in fact it does, because the reality states that there is some structure in all the data that we use. And so that's why I'm here today to talk to you about how to actually model this data, because despite all the tabloids that you may have heard where, oh, you know, you'd have this data, just throw it in there, or even worse, if you're coming from a relational background and you take your SQL data model and you throw it into MongoDB or in DocumentDB and you're wondering why it's so slow or why it's not working, you'll see why. That's most likely because of the data model that you create. And so, the goals of this session are to learn how to actually create a data model in 3 phases. So there's this methodology that you can use and you can iterate on to help you make your first data model and then continue growing it and evolving it as your application grows. And then once we know how to create this data model, we'll then go through and use it in an example. So I'm based in Las Vegas. So we're going to go apply this to a casino analytics floor application. We'll see how in this sample app we may develop a data model for it. And then finally at the very end, once we know how to do it, once we see how to apply it to an example, we'll then say, what are we actually modeling for? Because that is just as important when you're deciding and you're developing the data model that you are creating. So if there's anything you take away from this talk, it's that it is possible to develop a data model and it's absolutely necessary to create one, because without it you could have the application performance that you have will be greatly impacted. And a great use case, this might be hard to see, so let me try to zoom in. This is one post in the subreddit. Let me exit out of here. This is one post in the MongoDB subreddit where, by the way, I used to work for MongoDB, no longer, but where MongoDB, if your data model is right, you get a lot of people who are touting it or saying, this is amazing, the performance is absolutely staggering. If you don't have a good data model, you'll get posts like this. And the funny thing is, some people have the same type of problems. They almost have the same type of data that they're working with, but depending on how they structure it, depending on the data model that they use, they get completely different scenarios. And so it's very important to know that the data model is necessary and does exist. So we'll go now into the actual phase. How do you actually build a data model in 3 phases? The first phase is to make sense of your workload. So what does this mean? It means gathering everything there is to know about the data that you're working with in your application. And from this, you're going to get a lot of inputs. So the first input is to list, qualify, and quantify all the operations that are part of your application. What queries are you running? What are the most common queries? What queries do you not use at all, yet they still exist? What queries are making the most of your production workloads? What reads do you have? What writes do you have? Being able to list all of these things out not only puts a better picture of what's happening in your application, but is a very important part in this phase because this plays a part in the next phase. When you make sense of your workload, you want to go through all of your production logs and your statistics if you have them. Make use of those tools and see where do you get your traffic spikes, where do you not run any workloads at all. All of these pieces of information contribute to you understanding the data that you're working with and how your application is running. A big part of that is what are your current scenarios. So as you start to list all of these things out and you list all the operations that are running, you will have a set of current scenarios, right? This is our typical usage. This is what happens if you have maybe weird quarters where you know you may have spiky traffic or much more traffic. And then you can also have some predicted scenarios. If you know you're going to grow, if you're opening in a new region, if you're servicing other customers, if there's an outage, all of these pieces of information are key for you to know how your application is going to work with the data that you have. And then finally, it's always a good idea to not only consult the devs that are working on this application, but if you do have one, consult also a business domain expert, someone who knows the platform in and out, someone who may think of other things that you may not see while you're looking very closely at the application. Who sees the bigger picture? What are other entities that you might be missing? What are the things that you're forgetting? What are the really rare scenarios that you may not have encountered yourself, but you know happened 2 years ago when you weren't here? All of those things are absolutely key for you understanding the data that you're working with and understanding how your application actually uses the data that you use. So you take all of these inputs, you take all the information that you have about your workloads, and you get a lot of outputs from this. After you start to aggregate all of these pieces of data, you'll get things like all of the operations that you have. You'll get all of the queries that you are running, as well as the ones that aren't running. You'll get the data sizes that you're working with, so you can start estimating how your workloads are running. You'll get all of the indexes that you have, as well as the ones that are taking up a lot of space but are actually not being used. Or on the other hand, you'll find the indexes that you should be having because some queries show that they're slow, yet you're running them all of the time and yet you don't have an index. Oh my gosh, how come you don't have an index on this? And finally, you get a lot of assumptions about your application and your data. What did you assume was coming back every time you ran this particular query? What did you assume was part of this response that you were actually doing a join, or in this case with document databases, maybe an inner, it's a set. I'm forgetting, the operators are different. It's a set and also a merge as well, if you're trying to do something similar to a join in at least MongoDB. So all of these pieces of information are how you make sense of your workload. And that is phase one. This phase is not done in a day. It's not done even in a month. This phase can be done continually. If you do this often, maybe every quarter, or as you start to see problems or you do major enhances or add new features to your application, it's always a good idea to keep track of all of these things and how they may impact all of these pieces of information in your workload. So once you have all of those pieces, the next phase is to now map out and identify all of those relationships that come from the data that you get from this first phase. And in this phase, there's two things that you do. The first thing is you quantify and identify the relationships. So who has seen this type of notation before? Yeah. Mostly from a relational background, right? We have the same types of relationships in document databases too, right? We have one-to-one relationships, denoted in crowfoot notation here. We have one-to-many and we have many-to-many. And those exist in document databases as well, and the relationships that exist in document databases. One thing that is slightly different, that is also due to the large scale that we're seeing now with the amount of data we're able to capture, is something called 1 to zillions. So because of the massive amounts we get, like when you're dealing with sensors, IoT, where you're getting a bunch per second, like thousands of calls a second, or petabytes of data and the scales that some companies may be working with, sometimes this type of notation and this type of relationship is necessary to describe it, aside from the ones that we're already used to. And then when we do note this, there is a different type of notation that you want to use. So when you do have a 1 to zillions relationship, you'll want to list, the minimum, so that's usually 0 or 1. You'll list the likely amount, so this is where getting all that information about your data is useful, because you'll say this is about the average with this particular query. This is the likely amount for this particular relationship. And then you have the maximum, which could be this really gigantic number. And that is one way that we found that can fill that gap when it comes to this particular relationship. So you start to identify all of these things, you quantify them, you start mapping them out. The next thing you have to decide is, do I link or do I embed? And a lot of you might be thinking, wait, what's linking and embedding? You may have heard this before, and I promise you, it's actually very, very familiar in document databases. So in linking, and I will zoom because it might be hard to see. So in linking, we have here just a basic document, just to foreshadow the example we have coming up. So this is a very basic document. It's a casino in a collection of casinos. This might be a document describing a casino we're keeping track of. We have an ID, we have a name, we have the nicknames that might be used when people refer to this, etc., etc. So when we link something, it's literally taking something, and very similarly to a foreign key relationship, we refer or we link to another document based on its ID or some sort of identifier. So if you've worked with relational databases before, if you've used foreign key relationships, linking is exactly the same thing. So what is embedding then? Well, it sounds exactly like what it is. Embedding then is now taking maybe the most important information that you may always be querying. Let's say as part of the owner document, we always need the name, we need the headquarters, and when it was founded, we literally embed it into the document. So instead of linking, instead of using a unique identifier to point to a different document to get that information, we just put it right in the document. And this is important because all information that is accessed together should stay together. That's one of the core principles of data modeling, or whenever you're using document databases, that's one thing to keep in mind when you decide, do I link or do I embed? So when you're deciding which one to use, there are just some points to keep in mind depending on the type of relationship that you use. So if you do embed a lot of the documents in your parent document, if you have one-to-one or you have one-to-many relationships, the pros of this is that you'll have a single read, right? Because it's already part of that main document, you'll have them all together, which means you'll usually only require one read. You'll have a query that only gets all of the information at once. And on the same token, no joins, because now that you don't have to refer to a different collection to get that other document, you don't need to do any of those types of things in your queries. And in many-to-many relationships, a similar thing, you'll have that data all together, so you'll most likely have a single read. But the one thing that will happen possibly is that you'll have duplication of information. So let's say you do get all of that owner information and you embed it into the parent document, but you still need to have that owner information separately. Well, there will be some duplication of that. You'll have some embedded into the casino document, but then you might still have it in a separate document in the owner's collection. So for that, it's good to keep in mind that if that benefit outweighs it, if you need a faster read and you need all that information together, then maybe it's worth it to put it into an embedded state. And just to compare it to linking it, or when we say similar to foreign key relationships, when you link it in the parent document, again, one-to-one, one-to-many, or even many-to-many, you will have a lot of smaller reads because you will be accessing one or multiple collections, but you will also have many reads. So again, it depends on what is the thing that you are modeling for, what is most important in your application, and what do you need? Do you need really fast performance, or do you just need to make sure that this is happening as quickly as possible and ensure that it is going through? So great. First phase, we've made sense of our workload. We know what our data looks like. We know how it's used in our application. And we have some predicted scenarios of how it might be used in other scenarios. And now taking that information, we've made sense of what are the most important relationships are there and how we're going to link it or how we're going to embed it. So the last part is to now apply design patterns. So there's a very, very big caveat here, because once you've done phase 1 and you've done phase 2, you actually have a data model right there already. We only ever advise to do phase 3 if you actually start seeing performance problems or you find that the data model that you come up with does not suit your needs. So this methodology is very iterative, meaning once you've done phase 1, phase 2, you apply it to your application, it's working, it's great, you grow, you add features, it's not working, you go through this process again. And then at the end of the phase 2, if you still see that problems are occurring, then maybe you start thinking about applying design patterns. And we'll talk about this a little bit later where we decide what we're modeling for. But for the most part, you want to do the design patterns at the very end and only if you ever really need them. So with that said, what are design patterns? What do you actually do when you apply this design pattern? So a design pattern is just a reusable solution to a common recurring problem. And in this particular case, in this context, when you apply a data model to a document database, it's a data structuring model that solves common document data model use cases. So who here has, who knows the gang of 4 patterns in coding? Okay, and who knows like the solid principles? It's the same, yep, very good. I'm very happy to see that many people raise their hands. So it's those types of, it's like a framework for you to follow, and it's a way for you to solve problems that are happening in your application in a structured way. So what design patterns are available? There's actually a lot. There's 12. That could possibly be its own talk, but today I'll talk about a few of them that we will use in our example. So the very first one is something called the polymorphic pattern. So I know it's a little bit hard to see. Let's zoom in as much as we can here. So polymorphic, who's heard the word polymorphic before? You're probably pretty familiar with it. In this case, in the data model design pattern, polymorphic is very similar. It just means the fact that documents can change and that they're flexible and that the schema can change means that different documents can exist within the same collection, even though their fields are different, even though they may look different, and even though the shape of the documents are different. So how do we describe this example? So let's say in one of those casinos, we're going to place a bet. And in this bet, we have an application that lists all the different athletes that are, ever existed. And in this collection of athletes, we have Kobe Bryant, the late great Kobe Bryant, and we also have Serena Williams. So for Kobe Bryant, we are keeping track of the sport, the athlete name, the career earnings, and we're doing the same for Serena Williams. But because Kobe Bryant is a basketball player, he has some different fields that we keep because of the fact that he is a basketball player. So we may keep track of the championships we have, if he's in the Hall of Fame, and other things that are only related to basketball. On the other hand, for Serena Williams, we may keep track of, let's say, her events, because in tennis, you have different events, right? You may have singles and you may also have doubles. So taking that into account, polymorphic design pattern basically says because Serena Williams might have a slightly different document, we can change what her document looks like from this to this. So because she is tennis focused, we can change what her events look like to something like this. We keep an array of all the different types, the singles, the doubles, and also how those pieces change depending on what type of event it is. And this is key because having a document like this next to one that looks like the Kobe Bryant document is a very, very powerful thing to do, especially if you need to keep all kinds of different documents in the same collection. So polymorphic is really the basis for a lot of the design patterns because of the sheer fact that you can have different document models exist in the same collection. So the next pattern is something called the attribute pattern. And this is really, really useful when you have a really large set of documents but you have very specific fields that you're querying on. So if you're searching through a really large collection and there's only like 2 or 3 fields that you're searching on, attribute pattern is a really good thing to use for this scenario. So here's an example. We have a document here that has a movie. And in this case, let's say our application requires us to search for when the release date of this particular movie is. Well, if you can see the problem here, the way that we have our document right now is releases don't all happen on the same day. They happen on different days around the world. And sometimes it's a good thing because you get to see really, really good movies before us. And sometimes it's terrible because apparently I've heard Multiverse of Madness is not good. Who has seen it? Who's seen Multiverse of Madness? Is it really as bad as they're saying? We're waiting so long for this. Everybody's so disappointed. Anyway, I was about to watch it and then I saw the reviews and I said, really? So release dates are different. And so if we were to search by release date, well, this is going to be problematic because we have so many fields, 1 per country. And what that amounts to is you're going to have a really long list of indexes, right? Because we know we're going to be searching by the release date, and because we want that to be performant and want it to be fast, we will have to now create an index per field, and that is not a good way to do it. It's a very cumbersome way to do, to model this kind of data. So taking the attribute pattern into consideration, what we can do is something like this. So instead of having a particular individual top-level field of every country and its release date, we do something like this. We have a subset of it. We have an array of releases, and instead we have an attribute of location and the date. And what this allows us to do is no matter how many other countries we have to add, we just continue to add this within reason. That's another kind of bad practice, is to have subarrays that are really, really large in documents. But for the most part, when we have this, what our index looks like is now this. Because now we just have to create an index on that particular attribute. We don't have to create one per country and per top-level release field. And this results in a much nicer document and also better performance and better maintenance, because every time you have to add a country or a thing like that, you don't have to continue to add indexes and mess it up that way. So that is the attribute pattern. And then the last pattern I'll talk about is something that can apply to almost everybody, and that's something called the document versioning pattern. So this is very, very useful if you have a lot of documents that you need to keep track of for the changes. The caveat here is that these changes that occur, they don't happen too often, but they happen often enough that you need to keep whatever the current state is, as well as have a history of all the changes that you've made. And so one really good example of this is something super boring, but insurance policies. So here we have the original document here. So whenever you get insurance, right, you call, you say, I need to have something insured, you get a standard policy, and this applies to everyone. And when you get that initial policy, you have some things that you keep track of, right? You have the name of the person that is getting this insurance policy, and at the time that they started their coverage, in this case, Bilbo Baggins only had the Elven Sword when he first applied and got this insurance. And so this is the current state at the time that he opened up and got this insurance. But as things change, and let's say he acquired something else, like a One Ring, his insurance policy has to change, right? He wants to insure both the sword and the One Ring. So the document versioning pattern is very simple, because now what you do is you add a top-level field to indicate which revision is there, meaning you can always query against this particular field and ensure that you're getting the current state. And then to keep track of all of the changes, you will have another document kept in maybe a separate collection called revisions or policy revisions. And then you would add a document of what the last state was. You would have the last way that the last state that Bilbo Baggins' insurance looked like. And in this case, in the very, very first iteration, only had the Elven Sword. So this is a really, really good way to keep track of those. If he was to acquire something else, we would add then another new policy revision document, and we would have the current policy document maybe have a third item in the list or the array of items insured, and our revision would be 3, so on and so forth. And the really good thing about this particular pattern is that this can be applied even to existing systems because it's a single field that you're adding in your documents. And the one thing to keep in mind is because we now have 2 separate collections, so we have our current state and we have the history, the revisions that we've made, the one thing to keep in mind is to make sure you are querying against the correct collection. So in this case, you always want to query against whatever your current documents are. And those are just 3 of all the particular design patterns that are available. You'll see here that there are many more. We have something called the approximation design pattern, which are good for content management, catalog and Internet of Things, and so on and so forth. But in particular, the ones that we discussed were polymorphic, which you'll see the use case that they're good for, or something like a catalog application, content management, or mobile scenarios. We went over the attribute pattern, which has similar best use cases for that pattern, as well as a single view application. And then we also have document versioning, which again is great for personalization or content management or catalog. So this is kind of small, but I can tweet out this chart later too. But as you can see, there are many, many other design patterns, and this goes back to what I said, where it may not be necessary for you to add the design patterns at the very end, because sometimes when we go through creating a data model for someone will see this and they go, we want to use every single pattern. I said, are you sure? Because you may not need this. They're like, yes. And then they apply every single pattern, almost like retrofitting it just to be able to say they could use this pattern and that it's implemented. And then when they have to make a change later on, it's very difficult to understand what is happening. And they find that there were some cumbersome changes that needed to be made because it was so hard to understand, just because they applied design patterns that didn't need to be there. And in 3 phases, that's how you build a data model. That's how you do it for a document to database. So now that we know how to do this, let's actually see it applied, because I know sometimes going through an example is much easier to follow. So first thing is we make sense of our workload. So for our particular application, who's been to Las Vegas? Anyone? Okay. It's way more than casinos and buffets and strip clubs and drugs, I promise you. Like if you go off that area, just like any other touristy area, it's a really nice place to live. I've lived there for like 11, 12 years now and don't plan on moving. I mean, I might move here. It's really nice here. But so this is a typical casino, right? You have your table games, you have your slot machines, it's purposely dark. You don't know what time it is. That's the point, right? They want you to stay there. They want you to give all the money to the house. So for our application, let's say that the analytics that we want to look at are focused on these slot machines, right? We have all different kinds of slot machines from a few manufacturers. They're spread across the casino, and we want to keep track of certain things, certain characteristics. Very specifically, we'll have a lot of things in identifying our workload. We'll have things like the jackpots and the win chances of these slot machines. What are the bonus structures like? So if you've seen all the games, they have different kinds of games. There's the typical ones where you have to get 3 in a row or 5 in a row, or you have the Wheel of Fortune one, or you may even have a slot machine that has like 16 different games on it. If you've seen it, you get to select it. There's maybe poker or jacks or better, and then depending on the game that you select on that slot machine, that changes the bonus structure, the win rate, all of the characteristics of how the slot machine works. So with all of those pieces in mind, and knowing that these are the types of pieces of information we get for our application, we find that these are probably the most important ones that we'll have. So I'll zoom in here because I know it could be kind of hard to read. So after taking into consideration what is happening, we find that these are the most important operations. We have a couple of rights that are important. So we want to know the total player game time. And this we can grab because most players that play in the casino, you have a card and they use this so that they can get free drinks, or if they play a lot, they get free rooms and all that stuff. And every time they go to play at a slot machine, they put the card in, they play, they throw all their money away, and then when they've lost, they take the card out. And so for that particular action, we can hook into that. That can be a right that we have that we know because we can get the timestamp and show how long the player played at that particular slot machine. Then we have a few reads that are there, some set by the default, some set by the type of slot machine that is there. So we have the win chance rate, which part of it is set by the Nevada Gaming Control Board. So sometimes those are defaults that cannot be changed, and sometimes they have some leeway depending on the casino and how much they were able to negotiate that. We want to find all of the anomalies in win rates. So this is part of some of the fraud detection. So we have some analytics on both the table games, but also with the slot machines. Maybe there's an area that's winning a little too much. Maybe there was some jackpots that are happening too often. There are ways to detect whether or not these are legit wins or if they're not. And then we also want to see what type of slot machines are played, specifically which ones are doing the best. Because not only does the casino want to know this, maybe they want to have more of those types of slot machines come in, but maybe they also need to tell the manufacturers that they're leasing the slot machines from, hey, this one is not doing so well, or whatever, the branding on here is not great, whatever it is, they want to read into that as well. And this can also be read from the play time that we are grabbing, as well as the how many times a player goes back. Maybe they really like this slot machine, you know, it's hot, right? That's what they always say, it's hot, if I'm gonna win it, just $5 more, $5 more, $5 more euros, they're gonna go. And then finally, the last most important right that we find is the jackpot increases. So if you've ever seen a slot machine, there's like a whole round of them, like a ring, and then in the middle is this really big screen that has like the flashing jackpot, and it keeps going up, the number keeps going up. And so those types of slot machines, those are like a network. So as more people play and as nobody wins, that jackpot continues to increase. Sometimes it's only in a specific casino. Other times it actually spans across multiple casinos. All of those particular slot machines feed into a single jackpot. So somebody at the Bellagio, if they're playing as part of that slot network, let's say they win that jackpot, and that is connected to, say, another one at MGM. If somebody wins in the Bellagio, that jackpot is reset for the entire network. So that's another thing that we can keep track of, is how often the jackpot is increasing and if anybody has won. And we find and define that these are the most important workload operations we require as part of our application. So we've made sense of our workload. Next, we need to map out and identify what the most important relationships and entities are in our application. So after looking through all of the queries and the data that we're capturing, we find these are the most important entities. We find that we need to have a slots, players, and casinos collection because of the way that we're going to model our data. And we find that a lot of our relationships are really just one-to-many. So for example, slots and casinos, that's one-to-one because every physical slot machine, there can only be one, right? There's a specific serial number, and it can only ever physically be in one casino. And likewise with the rest of the one-to-many relationships, slots with bonuses, casinos and slots, we find that overall our application has it in a one-to-many state. Finally, we get to the point where we apply some design patterns. And in this case, because this is for a casino and because they are really, really curious about how their slots are performing, because money is king here, they want to make sure this is performant. So we are going to try to apply the design patterns that are necessary. So we'll end up with something like this. So we'll zoom in here. So the initial entities that we have here, we have some slots, we have some jackpots, we have some casinos, and we have the players. And these are the types of, or these are the fields that we want to collect about these particular entities. And where the design patterns come in, firstly, we'll show here that these that are bordered in the white, these are the pieces where we've decided to embed the information into the parent document. So you'll see here in the slots, we find that because of the way that we query the information about slots, we find that putting bonuses in as part of the slots documents really help and is better than referencing them or linking them. Similarly to jackpots, we're going to embed the participating slots. So again, to that whole network of slot machines that contribute to a single jackpot, we're going to embed that one. In casinos, we have some analysis on what the top slots are. So as we query on particular casinos, we find that we need that information at the same time all the time. So we are embedding the top slots per casino. And then for players, we've opted to embed both their membership status as well as their contact information. Because again, the way that we query our player information, these other pieces, which may still be held in different collections and in different documents, are actually needed in that particular query. So we've embedded them there in the player's document, which is the parent. Document versioning. We're using it here with our slot documents because slots machines can go through a different win chance that's being changed if the Nevada Commission or Nevada Gaming Board changes those percentages. Or if we'll see in the polymorphic pattern, if it's an older slot machine, maybe they are decommissioned. And we'll also see here, we have a revision for the player, because as your contact information change, or maybe you're not a high roller anymore, maybe you're broke and you can't spend $200,000 on a poker night, some of those things might change, not often, but they might change. It's good to keep track of those revisions because we want to have that history, because we want to see how a player has evolved while they have gone through our casinos, but then we also have this so that we can query the latest information as part of the parent document. We are using the attribute pattern here as part of the slots. So very similarly to the release dates with the movies, we're putting the bonuses here because of the way we query by the bonus multiplier chance and the particular location. So based on where that slot is, that bonus multiplier chance actually changes. If you notice, there are lots of slot machines that are right there once you enter in the door, and then there's some that are kind of hidden, like very in the middle of the maze of the casino, and those actually have different chance rates. And so in this way, the attribute pattern helps when analyzing those particular pieces of information. And finally, the polymorphic that I was talking about. So again, because of all the different types of slot machines that we have, polymorphic just means that we can have a document about a particular slot that looks like this, but we can have one that also looks like this. You'll see here, this one has a very different array here of game bonuses that may change depending on the game type that is selected. So this one might apply to a slot machine that has different games that you select. And then we can have another document in the same collection about a particular slot. Again, this one could be one of the older slots. Here we have the manufacturer, and here we have a decommission date. Maybe we remove this slot machine and we have a maintenance log for it. And this is very common for older slot machines. So if you ever go back there, you'll see that all of the wheels, they're actually all digital now. There are almost no more slot machines that have the mechanical wheels anymore. All of those are being decommissioned and sent to the archives, let's just say. And with that, that's how we've applied this particular process. We've made sense of the workload, we've gone through and mapped out the relationships and what the most important ones are, and then we did apply a few design patterns because we found it was necessary for this particular application. So now I want to go through here, and I feel this is actually way more important. I should probably put this in the beginning, but now that we know how to do it and how to apply it, the better question to ask is, what do we actually model for? Because you could be like that one particular example I gave, or they're like, yes, let's just apply all the design patterns, it's the most beautiful data model ever, it's perfect. And yet you still find problems with your data model. So modeling comes down to choosing between simplicity or performance. And there are these key things that you should keep in mind when you decide which one to model for. So if you want to model for simplicity, you want to take into account what the size of the project is. Is it small? Is it an early stage? Is it an MVP? Is it something that only a small set of people are working on? Which is the next thing. What's the size of your team? How many people are going to be able to keep this domain knowledge in their head? How easy is it to transfer between people? You want to take into account the size of your data. So that's where taking all of the workload and making sense of it. When you have those pieces of information where you're dealing with only a small set of data, or you're using shared or hosted resources, then you're most likely have a project that only warrants a very simple data model. And then likewise, your expected scale. If you don't have too many users that are going to be using this, or you only have very low traffic, again, the simpler data model is usually the better one to use. And then, as you can imagine, if you're modeling for performance, you want to take into account probably the opposite things, right? If you're a larger team or a larger project, if you're distributed, if you are over sharded clusters or multiple regions and you're dealing with projects that are much more complex like that, and if your scale is much larger, where you Hello, testing, testing. Yay! So, yes, for performance, we want to use as many patterns as necessary. who wants both? Because everybody wants to eat their cake and have it too, right? So if you want both, you will fall somewhere in the middle, right? So you will go look at most of your operations. You'll get that full list. Maybe you'll focus on the top ones or the ones that are being used, for example. And you actually want to go through and quantify all of them. Meaning you want to know per request, how much traffic you're using, the data sizes. You want to get as specific as possible when you are quantifying those operations. Again, you'll still want to embed and link as necessary. Maybe you can get away with mostly embedding, depending on how middle you fall. And then you will want to use a few patterns, or again, because you want to have simplicity, you only have the patterns applied as you start to see performance issues occur. And with that, salamat, that means thank you in Tagalog. I hope you learned something. I'm very happy to answer questions. Thank you so much for choosing me. I have another talk after lunch. I don't know why I agreed to this, but if you're interested, my other talk is building a quick serverless game in MongoDB, Realm, and Atlas. And it's very interactive, so if you're feeling like you're falling asleep after lunch, I highly suggest you come to my talk if you'd like. But thank you so much.